Alright. We're going to start by moving 11. Right? I want to add 11 to both sides. So I get 7p squared minus 2p plus 11 equals 0. What that does is it gives me my A, my B, and my C. So I can plug it into my quadratic formula. Okay? Because remember, if ax squared plus bx plus c equals 0, then x equals this. Right? So I just got to plug it in. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And then I plug in. I look for my b. Oh, that's this guy. Negative 2. Negative 2. Right? I look for my a. That's this guy. 7 and 7. I look for my c. That's this guy. 11. Okay? Uh-oh. Is that really it?
Why do you pull out the 2 and the 7 at the bottom?
Why is there a 2 here? Because it's part of the 2a, the formula. But this isn't good. Yeah, that's right. Positive, positive. 4ac. That's minus. Alright, so with you guys, what's going to happen is this is undefined. Is that what is coming up in your answer key? Yeah, no solution. Duh. Because what's happening here is I'm going to get, well, what's a negative times a negative? Positive. So I got 2. What's negative 2 squared? Negative 2 times negative 2. Positive 4. Alright? Minus, what's 4 times 7 times 11?
4 times 7 times 11.
Yeah. So that's like 28 times 11. And 28 times 11, here's a little, oh, this is kind of messed up, but a little trick is 2 and 8 make 10, so it's 308. I'll double check it. 28 is 280. How did you do that? Right? Plus 28 would be 308. But the trick for 11 is, like if I was going to do like 33 times 11, that would be 3 and 3, and this would become 6, because I just add those two pieces. Right? So,
How you did the 2 and 8, you just added
2 plus 8 is 10, right? So that's a 0, and I added 1 to the 2. Kind of a little trick for 11. So it is 308. I just wanted to remember that I knew the trick, right? To double check it. All right, and then I say, well, that's minus that. Well, that's going to be 304. What's 2 times 7, though? 14. So what I'm going to get is 2 plus or minus the square root of negative 304 all over 14. Now, for your test, all you have to do is come up with, hey, this is negative, so this is no solution. But I don't like to teach that to my students. Because next year, guess what I got to teach you? That there is a solution. It's just not real. So there's no real solution.
It's a real no solution?
There's no real solution. Right? It's called imaginary. Okay? And what happens here is I get this negative 304. Right? And I'm going to break down by taking what's called I. Has anyone seen the letter I before in math? right? What is it?
I.
No. I is a special letter in math, and we use it to say it's the square root of -1. So I squared is actually -1, right? Because it's the square root of -1.
So it'd be I 3 negative 3 over 4.
So what I'm going to do is I'm going to pull out I, which would take out the negative, right? And then remember all that stuff we used to do with the radicals? Remember? 2 goes into this how many times? It looks like 15 and 2. And 2 goes into this how many times? Looks like 7 and 6. And 2 goes into this how many times? It looks like 3 and 8. And 2 goes into this how many times? Looks like 1 and 9. And then nothing goes into 19 except 19, right? And then we go through and we do our circles. Well, this comes out because it's I. It's special. But everything else is only by pairs. Pair and a pair, right? So we have a 2 and a 2 and an I. So we get 2 times 2 times I, and what's left in the box? 19. So what happens here is we get 2 plus or minus 4I square root 19 all over 14. We got one last step. What goes into 4, 2, and 14? 2. How many times?
Once.
Once.
Twice.
Twice. 3 times. Oh, sorry. I'm always doing that today. So then we've got, and how many in the 14? 7. That's it. Okay? So this is what we're doing next year. You can practice it now. If you do it on your test, I give you extra credit. Okay? All you need to tell me is no real solution, because it's not real. This is imaginary. Okay?
It's imaginary next year.
It's imaginary. And I'll show you why it's imaginary. Okay? In fact, I'll show you here. Look at this. We talked about this today in class. And we were like, hey, we drew this. Right? We drew this. We said, hey, what's going on here? Does this cross the x-axis? No. So that's what's happening with that one.
Did we do that yesterday?
No, I did this in third period.
Third period?
But what's happening here, third period. And what's happening here is this, right? There's a shadow of this, and it will come up with these x values, but they will be what's called imaginary, right? And it's the shadow of, I call it the shadow effect, right? The imaginary numbers that you find are if this were flipped over, well, where they would cross the x-axis, okay? Where do they use this? Computers, a lot, okay? We need to use imaginary numbers in a lot of things, in physics, right, chemistry, but also in computers. So if you're becoming a tech or something like that, this is the one thing I worked with a lot of my friends who became techs, who didn't want to get a college degree, but they wanted to go in the computer field and make lots of money. Now they make more than me, and all I had to do is teach them imaginary numbers, right? And some algebra and stuff.